Hi everyone, today we start our next unit. Unit 3.2 is all about polygons. In today's lesson, we're going to be taking a look at something called a convex polygon. A convex polygon is defined as a plane figure and it is formed by coplanar segments. And more in terms that are easier to understand, basically the figures that you think of in geometry, like a triangle or a quadrilateral or even a pentagon, would be convex polygons, as long as none of the vertices is within the interior. So an example of something that's not convex would be this little picture where one of the sides is sort of caved in. See, that point right there is within the interior of the region, so that's called a concave polygon. So what we study in geometry are convex polygons. Also in a convex polygon, each segment intersects, or each side intersects with exactly two other segments, and they only intersect at their endpoints. So if you see a segment going through a polygon, that's not a side of a polygon, that would be called a diagonal. When we refer to polygons by name, we do so according to the number of sides. So for example, if a polygon has 3 sides, we know that as a triangle. Where'd that eye go? I have 4 sides, we call it a quadrilateral. You can test yourself and see how many you can name. Go ahead of me. 5 sides, it's a pentagon. 6-sided figure would be a hexagon. A 7-sided figure, this one has kind of a funny name. It's called a heptagon. An 8-sided figure is called an octagon. You're probably familiar with that one. The 9-sided figure is called a nonagon. 10 sides means it's a decagon. Think of decade. Decagon. An 11-sided figure is called an undecagon or undecagon. We're only going to go up to 12. A 12-sided figure is called a dodecagon. Now, from earlier this year, we know that in a triangle, it has 3 sides. Obviously, it's one triangle. If we were to find the sum of all 3 angles in this triangle, we know that they would add up to 180 degrees. Okay? In this quadrilateral, we have 4 sides. If we try to divide it into triangles, we can go from one single vertex and draw only the diagonals that will create triangles using the sides of the figure. You see that we have one diagonal, but it creates 2 triangles. Now, the sum of the 3 angles in each of those 2 triangles is 180. So when we add 180 and 180, we get 360 degrees. Okay, in our next figure we have a pentagon. So check it out. Drawing the diagonals from one vertex. I have one diagonal here, one here. I should go all the way to that point right there. All right, we have 1, 2, 3 triangles. So 5 sides gives us 3 triangles. And if we were to add 180 plus 180 plus 180, we'd have a total of 540 degrees. By the way, all of these are in degree measure. Okay, if we have 6 sides, again, check it out. Go from one vertex. We have one diagonal here. There's a second. There's a third. So 6 sides gives us 1, 2, 3, 4 triangles. So the sum of the angles would be 180 plus 180 plus 180 plus 180. That's 720 degrees. So in case you haven't noticed, there's definitely a pattern here. If we let the number of sides be n, the number of triangles formed will always be 2 less, n minus 2. Check it out. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. Okay? And then if we take that n minus 2 and we multiply it by 180, 1 times 180 is 180. 2 times 180 gives us 360. 3 times 180 gives us 540. And 4 times 180 gives us 720. This gives us a way to find the sum of the interior angles of a polygon without having to draw in all those diagonals. Okay, so here's the formula. You take the number of sides and subtract 2 and then multiply it by 180 degrees. Works every time. Okay, so somewhere in the margin of your paper, draw a triangle. But what you're going to do is extend each side a little bit, okay? Now imagine if we had an angle of 30 degrees, and let's say this one was 90 at the top, just because it looks like 90. If I can get it to... And that would force this angle to be 60 degrees right here. Then we can find the measures of those exterior angles. Exterior means it's outside the figure. This angle would have to be 150 degrees because the interior angle and the exterior angle form a straight line, so they have to be supplementary or add up to 180. This angle right here would have to be 120, and this angle over here would have to be 90. If this is 90, that has to be 90. So check it out. Take those three angles, 150, 120, and 90, and add them up and see what we get. 360 degrees. Now let's try it with a square. If you have a square and you extend each side, okay, if this is 90, this has to be 90. 90, 90, and so forth. Okay, so check it out. If we add up the 4 90-degree angles that are on the exterior, 4 times 90 equals 360. So unlike the measures of the interior angles, the sum of the measures of the exterior angles of a polygon, as long as you only have one angle at each vertex, it's always going to be 360 degrees. Okay, a regular polygon is a polygon where all of the sides are congruent and all the angles are congruent. In other words, an equilateral triangle is an example of a regular polygon. It has 3 congruent sides, 3 congruent angles. A square is an example of a regular polygon. It has 4 right angles and 4 congruent sides. Okay, so this means that with a regular polygon, we can find the measure of each interior angle and each exterior angle. So to find the measure of one interior angle of a regular polygon, first find the sum of all the angles. That you're going to find by doing n minus 2 times 180, and then you divide by the number of sides. For example, let's say we want to find the measure of each angle of a regular hexagon. So a regular hexagon obviously has 6 sides and they're all congruent to each other, but we want to focus on the angles. These 6 interior angles would all be congruent. So if we did the sum of all 6 angles, which would be 6 minus 2 times 180, and then we divide it by 6. Okay, so for a regular hexagon, the sum of the interior angles would be 4 times 180. And we want to divide by 6. 4 times 180 is 720 degrees. Divide it by 6, and each interior angle would be 120 degrees. Okay, to find the measure of one exterior angle, you divide 360 degrees, that's the total of all the exterior angles, one at each vertex, by the number of sides. Okay, so for our regular hexagon, using that same example, so if we take 360 and divide it by 6, we end up with 60 degrees. So check it out. The interior angle is 120, exterior angle is 60. It's no coincidence that 120 plus 60 is 180. Remember, an interior angle and an exterior angle have to be supplementary. Okay, finally, we're going to summarize these formulas into a little chart so you can use it to help you on the CYU in your homework. The sum of the measures of the interior angles of a polygon is n minus 2 times 180. The sum of the exterior angles, one at each vertex, is that magic number of 360. The measure of one interior angle of a regular polygon, well, you take your n minus 2 times 180, and you divide it by the number of sides that you have. And the measure of one exterior angle of a regular polygon, you take our magic number of 360, and just divide by the number of sides you have. All right, good luck on the CYU and your homework, and make sure you speak up if you have questions.